So in this video here, we're going to have a go at some questions, this time about when you've got a wall situation. Okay, so last time we did dealing with situations of a peg, and then the other main one, probably the most common one here, is a wall. So we're going to typically have the ground, we're going to have some sort of ladder, okay, and then this time the thing that stops it hitting the ground is going to be a wall. So we're going to have a normal reaction and usually, but not always, some friction. And we're going to also do something at the wall this time. So I think most of the time we have a smooth wall, so it's normally just like that. What are the arrows? There's normally the ladder itself. Sometimes there's also somebody, let's say, like sitting on the ladder. So this is roughly kind of what the situation is going to look like, okay? And then the moments being equal, left being equal to right, up being equal to down, that's going to be the way to go, okay? So a uniform ladder of length 4, so putting the 4 out of the way is quite a good way to do it, or maybe even break it up, 2 and 2. It weighs 6, so we're going to do 6G. Rough horizontal ground, yeah, so it is what we just talked about, so R and mu R. A smooth vertical wall, so you can draw the wall on if you like, or you could just draw the other one. If you do an S, just make sure it doesn't look like a 5. And then we've got 70 degrees. Okay. On the point of slipping is just another way of saying equilibrium. Okay, calculate mu. So let's go through those steps then. So here's a neater version of the diagram that I've just borrowed to speed it up a little bit. And one number that's quite useful to give you is to start by saying, well, if that's 70 degrees, this will be 70 degrees. Okay, because of alternate angles. If you think about these as being parallel lines with one another. So what do? We go through our usual steps. Here I'm going to do the up, down, left, right first, because you're going to see that that is relatively easy. So all of the forces to the left is just S, and that's equal to, they've called it F. You could jump in and you could call it mu R as well if you want to. So I'm going to call it mu R just because I think that's slightly more useful. Up equals down. Let's do up equals down. So that's R equals 6G, I think that's everything. So R and 6G, S. Yeah, lovely. So you see that step there is really quite easy. The bit that's going to be more involved is the moments. So I'm going to take my moments from here, as I often do. And yeah, let's just start doing that then. So I'll zoom in a little bit, I think, on the 6G just to show you what I'm doing. I'm going to show you two approaches this time, okay? So the 6G, the moment. So one way is we can just draw the ladder, which is 2. I can make this arrow longer, and I can use the 2 and the 70 to express this distance instead. So if I do that, that's cos, so this must be 2 cos 70. That's my distance, that's my force, they are perpendicular, so that must be 12g cos 70. Okay, so that's approach number 1 to how you can work it out. Let's do approach number 2 underneath for you. So the other way that we could have done it is we could keep that 2 the same, and instead of drawing that as 6G, if we sort of do our right angle triangle like this, that's 70. You will find that this one here is 6G cos 70. So I've got my force, I've got my distance, they are now perpendicular to one another, 12G cos 70. Okay, so however you choose to do it, those numbers will be the same. So let's just jump back over here. So clockwise is 12G cos 70. So what's the anti-clockwise then? What's stopping it? It must be this S force up here. So let's have a go at resolving this force. So you can draw it out like that, and then if you do that, might need a little bit more space. So then if that's 70, so sorry, that's S, that's 70, the triangle, although it's not taking place here, I'm just showing how the triangle's made, okay? So that's opposite, isn't it? So that's sine. So that's going to be S sine 70, and then it's 4, so that's 4s sine 70. That would be the moment. Okay, I'll just double check my numbers before we go too far. Yeah. Okay, so 4s sine 70. So that's one way you could do it. If you want to do the distance trick, what you do is you make this arrow longer, so it says s. You say that this is 4, and then there's a couple of different ways you could do it. If you call this 70 up there, then it must mean that if you want to express the distance in a perpendicular way, well, that is 70, its opposite is 4, so that can you see there, if you do it that way, you get 4 sine 70, and 4 sine 70 times s is also 4s sine 70. Okay, so whichever way you like to work that one out, that is going to be what the anti-clockwise moment is. So what do we call it? 4s sine 70. And then, as we sort of were doing before, it's a case of using everything together. So I noticed I've dropped G on that one there. What's the goal in this question? So I've got 1, 2, 3 equations. Calculate the coefficient of friction. So this is the one that has the coefficient of friction in it. So I could rearrange that to say mu equals S over R. Mu equals S over R. Yeah, S. So S, let's do some extra work with this one here to get S on its own. So if I divide by 4 both sides, I get 3G cos 70 equals S sine 70. They've both got 70 in them, so that's convenient because it means that S is equal to 3G. Cos over sine is cot 70. Okay, so the S part is this bit here, which is 3G cot 70, and R is just 6G. Okay, you can even cancel those as well. So if you want to make it a little bit nicer, what you get if we make it a little bit nicer, you get 1/2 cot 70, which ends up being, so mu ends up being 0.182 is the number I've got written down here. Okay, so to sort of summarize, when you've got a wall situation, the left, right, up, down will often be quite a lot easier. Okay, the moments, you saw I had to do moments in 2 places. So this one here, the weight, is going to become very familiar to you because you have to do that one all the time. And then these were the 2 different ways that I handled this reaction from the wall that it was leaning against. Okay, so this was rigid bodies, this time dealing with a wall.